we're going to look at the compound angle formulas. First of all, let's start with a unit circle. And let's rotate around to this point here. Let's call that angle A. So that would have coordinates cos A, sine A. What would have coordinates cos A, sine A? That point, that dirty, great point there, that's a point on the unit circle. It's a point on the number plane, but specifically at the moment, it's a point on the unit circle. I'll pick another point on the unit circle, maybe this one here, and I'll rotate around, let's say, B. Could be the size of that angle. So maybe it's 10 degrees or something like that. Its coordinates are cos B, sine B. Now, remember, this is a unit circle, so the radius of the unit circle is 1. So bear that in mind, that the green line that I've drawn there is 1 unit long, and the blue line that I've drawn there is 1 unit long. Now, the question's going to be, what is the distance between those 2 points? And what I'm going to do is I'm going to find it in 2 different ways and then equate those ways together. So there's 2 different ways that we're going to find that distance. First of all, I'm going to treat them like 2 points on the number plane. You know the old distance formula. The distance formula on the number plane is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's just Pythagoras' theorem on the number plane. So if you don't want to use the distance formula, just work it out using Pythagoras' theorem. But that orange line would be that. Now, you know, this can be my x2, y2 up there, if you like, and that can be my x1, y1, if you like. So in that case, I'm saying that this will be the square root of x2, which is cos A, minus x1, which is cos B, plus squared, and y2, which is sine A, minus y1, which is sine B squared. I'm saying that's what the distance between those 2 points, that orange length, is. Now, if you want, you could write that as cos squared A. That's when you square cos A, instead of writing cos of A, instead of writing cos of A all squared, we write cos squared A. That's just the notation of it. Minus 2 cos A cos B plus cos squared B. That's expanded that first set of brackets there. And now the second set of brackets, this one here, I'll expand, and I will get sine squared A minus 2 sine A sine B plus sine squared B. It's plus because it's minus, but it's been squared. I can simplify that because look at the cos squared A plus sine squared A. They go together, and we know that identity, that cos squared A plus sine squared A is 1. And we see that appear as well here. Cos squared B and sine squared B equals 1. Okay, so when I do this simplification, I get the square root of, and it'll be minus 2 cos A cos B plus 1 minus 2 sine A sine B plus 1. So I end up with the square root of 2 brackets 1 minus, in fact, maybe I could take that minus out of it. How about that? I'll go 2, because 1 plus 1 is 2, minus 2, and have cos A cos B plus sine A sine B. So that's what the distance is, using the distance formula to find the distance between the green dot and the blue dot on the number plane. But look, it's in a triangle. And I'm just going to peel that triangle off here and draw it over here. And I know that the two radiuses of the circle here are 1. So the two sides of that triangle coming out from the origin there are 1. I'm trying to find this side here. I'll just call that D. And I know this angle here is angle A minus angle B. Right? Angle A goes from the x-axis all the way to the line joining out to cos A sine A. And angle B is the little green angle. So the difference between them is that angle in the triangle. I'm going to use that triangle and the cosine rule to find the size of D there. So let me redraw that down here. I'm going to use this triangle here with angle A minus B to find that length D. So here we go. D squared equals A squared plus B squared minus 2 times A times B times cos of. All right, so that's using the cosine rule. So D is equal to the square root of 1 plus 1, which is 2, minus 2 cos of A minus B. Well, that's a bit more quickly I've got to the answer. I found it in two different ways. I've found that here, I've found that D is equal to square root of 2 minus 2 cos A cos B plus sin A sin B. And the other way, I found that D was equal to that. So that means I can equate the two right-hand sides together because they're both equal to D. I can say that root of 2 minus 2 cos A minus B is equal to root of 2 minus 2, I'll just go up and have a look what it said, cos A cos B plus sin A sin B at the bottom of that page there. Cos A cos B plus sin A sin B. All right, square both sides. 2 minus 2 cos A minus B equals 2 minus 2 cos A cos B plus sin A sin B. All right, take 2 off both sides. So minus 2 cos A minus B equals minus 2 cos A cos B plus sin A sin B. Divide both sides by minus 2. Cos A minus B equals cos A cos B plus sin A sin B. I just used the distance formula to find the distance between 2 points on the number plane and the cosine rule to find the side of a triangle, but we were finding the same length, so I equated them together and I found this rule here, which is going to be the basis for us developing all our other rules. Cos of A minus B is cos A cos B plus sin A sin B. Okay, well, let's develop the other rules from there. So let's let B in this one above equal to minus B. All right, we're going to replace B with minus B. All right, so now it says cos of A minus. Now instead of B in that first set of brackets, I'm writing minus B. That means over here, instead of B, I write minus B. Now, I'll just remind you of a couple of rules that we should know. You should know that cos of minus x is the same as cos of x, but sine of minus x is minus sine of x, right? That's because cos is an even function and sine is an odd function. We did that in our lesson 2 periods ago for advanced. Well, that's important here. Okay, so this says cos of A plus B, because a minus of a minus is a plus. Now this is just cos A cos B, because cos of minus B is the same as cos of B, minus sine A sine B. I've changed sine of minus B to minus sine of B because that's the case. So instead of having plus sine A sine B, I've got sine A times minus sine B, which is minus of sine A sine B. So that gets me my next rule. I've got the rule for cos of A minus B here. I've got the rule for cos of A plus B, which is just got by throwing a minus B in for B. All right, now there's a rule that says sine of 90 minus x equals cos of x, and cos of 90 minus x equals sine of x, right? Remember, we did this the other day in advance. It's the complementarity that, so these are complementary, these rules. I'm going to use that here to get sine out of cos. So what I'm going to do is I'm going to go, instead of B, I could make that 90 minus B. I could put in there if I wanted to. Or I could change A to 90 minus A. So I'm trying to get 90 minus in there so I can have that complementarity. So why don't I go from this rule here and call it 90 minus A instead of A. I'll write that down. I'll write what I'm going to do. I'm going to change A to 90 minus A in this rule, right? Disappeared. So I've just got room to be able to see it. I'll write what would happen down. I would get cos of 90 minus A plus B equals cos of 90 minus A cos B minus sine of 90 minus A sine B. So I've just used this rule up here, but wherever I saw an A in that rule, I threw in 90 minus A. I just made the angle be 90 minus A, because A and B are just angles. All right, so I'm just going to rearrange this slightly and go, well, that's the same as cos of 90 minus A minus B. Think about it. If you expand all that out, you'll still get 90 minus A and plus B, because of a minus will be a plus. So you'll still get what's written above there, 90 minus A plus B, but I've just written it as a complementary thing. So I'm going to appeal to this rule in a minute, that cos of 90 minus x is the same as sine of x, all right? Because then I'll be able to say that there is the same as sine of A minus B. Cos of 90 minus A minus B is the same as sine of A minus B, because of that rule that I just pointed out there. So I'm going to do that there, but let's do this line. This line, we've got cos of 90 minus A. Now, cos of 90 minus A, by that very same rule just there, is sine of A. And then we've got cos B. Sine of 90 minus A, by that rule up there, sine of 90 minus A is cos of A. All right, so sine of A minus B is sine A cos B minus cos A sine B. Hey, I wrote that wrong in the line above. It was sine B. It says sine B, it's sine B. There's the first rule for sine, a rule for sine. Now I want to get the other rule for sine. So I can just replace b with minus b in there to get the other rule for sine. So the b in there, let's make that be minus b. So I'm going to get sine of a minus b equals sine of a cos of minus b minus cos of a sine of minus b. Now we know that that'll say sine of a plus b on this side. Minus of a minus is a plus. Now we know that cos of minus b is just cos of b. And we know that sine of minus b is minus the sine of b. Now those two minuses then, if this minus is going to come out the front here, it's going to connect with that minus and we're going to end up with a plus there. Right? So we're going to end up with our final rule here. Sine of a plus b equals sine a cos b plus cos a sine b. Okay, so there's 4 rules. We've got sine of a plus b and how it expands out, sine of a minus b and how it expands out, cos of a plus b and how that expands out, and cos of a minus b and how that expands out. I'm going to write those 4 rules down right here. 1, sine of a plus b is sine a cos b plus cos a sine b. And 2, cos of a plus b equals cos a cos b minus sine a sine b. And 3, sine of a minus b equals sine a cos b minus cos a sine b. And 4, cos of a minus b equals cos a cos b plus sine a sine b. So there's our rules, which can be used for some fantastic things. But poor old tan is crying out, that's not fair. What about me? What about tan? What about tan of a plus b? What about tan of a minus b? Well, we have a rule that tan of x is sine x on cos of x. So I guess tan of a plus b could be worked out by doing sine of a plus b on cos of a plus b, couldn't it? So let's do that. Let's take numbers 1 and 2 and put them, the right-hand sides, on top of each other in a fraction. So I'd be saying sine a cos b plus cos a sine b on cos a cos b minus sine a sine b. All right, so we need to end up with tan out of all this. So I'm just rewriting this to give myself a little bit of room. Okay, now how am I going to end up with tan? Well, tan is sine on cos, isn't it? All right, so what I'm going to do is I'm going to divide the top and the bottom by the same thing. I'm going to divide everything on the top by cos A, cos B. Every single thing on the top by cos A, cos B. So I really haven't done anything to the actual whole equation because that's equivalent to timesing by 1. But what has happened is some things are going to become tans, and I'll just circle them in green, like sine A on cos A, that's tan A, and sine B on cos B, that's tan B, and sine A on cos A, that's tan A, and sine B on cos B, that's tan B. And of course, cos B on cos B, that's just 1. Cos A on cos A, that's just 1. Cos A on cos A, that's just 1. Cos B on cos B, that's just 1. So everything's going to simplify out pretty reasonably there. And it's going to give me tan A times 1 plus tan B times 1 on 1 minus tan A tan B. All right, like we just said, that's tan of A plus B. Now I could use that whole same method for finding tan of A minus B, or in this formula that I've just found, I could just replace, I could just say I'm going to replace B with minus B. If I do that, I get tan of A plus minus B equals tan of A plus tan of minus B on 1 minus tan of A, tan of minus B. But we know tan is an odd function, so tan of minus B, what's that the same as? Yes, minus tan of B. Tan of minus B, sorry, I was just going to do that in a different colour. Tan of minus B is the same as minus tan of B. So when I fix this all up, I get tan of A minus B equals tan A minus tan B on 1 plus tan A tan B, because we've got minus of minus tan B, which is going to turn it into a plus. And so we get that formula there. So altogether, we get these formulas. I'll give myself enough room to write them down. We get the following formulas. 1, sine of A plus B equals sine A cos B plus cos A sine B. And 2, the same formula, but with the negative, is sine A cos B minus cos A sine B. So they're the sine ones. Then the cos ones, cos of A plus B is equal to cos A cos B minus sine A sine B. And cos of A minus B is equal to cos A cos B plus sine A sine B. And tan of A plus B is equal to tan A plus tan B, on 1 minus tan A tan B. And finally, tan of A minus B equals tan A minus tan B on 1 plus tan A tan B. You can see that they're all closely related. Whatever the plus one does, the minus one's very similar, but it does the opposite. And I believe on the formula sheet, you're only given this guy and this guy and this guy. But you can easily get the other ones from it. You need to be able to work with all those 6 formulas. Now, I don't have much more time, but I'll just give you one exciting example of how these formulas could be used. You might be asked to find tan of 75 degrees, and you'd be like, what about tan of A plus B? Could I use that? Yes, I could, because 75, well, that's the same as what, 30 and 45? Right? Now, I pick 30 and 45 because they're angles that I know about. Right? I wouldn't go, 70 plus 5. Do you know what tan 70 is and tan 5 is? No. But do you know tan 30 and tan 45? Yes, from our exact value triangles. From those triangles, 60, 30, 1, 2, root 3, and the 45 are 1, 1, root 2, and that's 45 and 45. That's actually a straight line on that hypotenuse of that triangle. It's just space is curved, so it looks curved. So this is actually tan of 30 plus 45. Why is that good? Because I'm going to use tan of A plus B. I'm going to use tan of A plus B formula, which is tan of A plus tan of B on 1 minus tan of A tan of B. All right, but For A, I might use 30, and for B, I might use 45. So that'll be tan of 30 plus tan of 45 on 1 minus tan of 30 times tan of 45. So I can use that to find out what tan of 75 is in exact values. It's 1 on root 3 plus 1 on root 2 on 1 minus 1 on root 3 times 1 on root 2. So it's actually root 2 plus root 3 on root 3 times root 2. I'm just a common denominator in the top line. And root 3 root 2 minus 1 on root 3 root 2. I just common denominated the bottom line. So that's root 2 plus root 3 on, they'll cancel, and it's root 6 minus 1. And then, look, you could do what you need to make it look like whatever a question might ask you to make it look like. But the point is, you can actually find the exact value of some angles that you can get from combining other angles, in particular the exact value angles. So the exercise you're going to be set to do is going to be using those rules of compound angles, like sine of A plus B, cos of A plus B, tan of A plus B, to work things out. They become very, very handy because later on, you can use it to prove things like, you know how we know that sine of 180 minus x is equal to sine of x. That's a rule that we know. We know it from the all stations to central and sine of the related angle there, if that's x there by symmetry, right? Sine of 180 minus x is the same as sine of x. We've learnt that one. But you could expand that using sine of A minus B if you wanted to prove it, like rather than the whole argument through the unit circle, because that's sine A cos B minus cos A sine B. So if I expanded that out, I would say, well, sine of 180 minus x is sine 180 cos x minus cos 180 sine x. Right, now sine 180 is 0, so it doesn't matter what cos x is, right, because that'll be 0. And cos 180 is minus 1, and then you've got sine x. So this is minus of minus sine x. This is just sine x. So you can actually use these rules to prove or to remind yourself of all the other rules about 90 minus x or 360 minus x, or you could do 90 plus x. You could go, oh, cos of 90 plus x, I'm wondering about that. Well, you can use cos of A plus B to work that sort of thing out. Cos of A plus B is cos A cos B minus sine A sine B. So you could say, all right, I'm going to use that. I'm going to go cos of 90 plus x, and just go, that's cos 90 cos x minus sine 90 sine x. Now cos of 90 is 0, so really that's going to be 0, that term, and sine 90 is 1 sine x. So that's actually equal to minus sine of x. I've just figured out in a very quick and easy way that cos of 90 plus x is the same as minus sine of x, right? It is a rule, it is an identity, but it's not one that you've learned and you are tested on, sort of thing, but it's one that you might want to use, or it's one that you might be asked to prove. And you're allowed to use any of these things that you've learned in Extension 1. You are allowed to use them in Advanced. They've specifically said that. So these are pretty cool rules. I hope you enjoy doing the exercise with them. Have a look on your formula sheet, which ones they have given you, and be able to easily get the other ones you need from that.